Alright, so everyone, good afternoon. Today we're actually going to start the second half of, or I shouldn't say half, second portion of this unit, which is, polar coordinates and vectors. So this is the part of the group project that we didn't get to, cover, but it's okay, we're going to cover it now. So your aim for today is how do we write vectors in component form? And this is going to be the introduction to vectors in, through the lens of mathematics. So we're going to see like how to deal with vectors algebraically. Okay, for your do now, I want you to think back to physics class and think of some examples of vector quantities. Okay, so take like 30 seconds to think about that, and then afterwards I'll have you type in the chat. All right, so I'm gonna stop you here. Um, so at this point, just feel free to type in the chat what your responses were. So what ideas or vector quantities did you come up with? Okay, so I see velocity, momentum, force, acceleration, displacement. All right, very nice. Acceleration, good. Velocity. All right, yeah, very nice, very nice. Momentum, okay. Good, good. Yeah, so I think that should be pretty much it for like what you've covered in physics so far. Let me scroll up to my responses. Okay, so yeah, we got the same things: displacement, velocity, acceleration, force, and momentum. Okay, but um, what these quantities have in common is you know two things, or I should say are two things, right? Magnitude and direction. Okay, so you might remember from physics class, right? The definition of a vector: it's a quantity that has magnitude and direction. Okay, so please have that in your notes. I know you might have seen it already, but just conceptually, we need magnitude and direction. Okay, and then after you finish copying this definition down, I'm gonna have you copy this, right? So again, today we're going to look at vectors through a mathematical lens. So just how to work with vectors algebraically. Okay, so again, make sure you have the highlighted text in your notes. Okay, so in the meantime, can someone read this text right here? So where it says analytic arithmetic of vectors.
All right, so the definition of a, oh, I don't know why I'm echoing, but all right. The definition of uh, a vector is a quantity that has a magnitude and direction. Analytic arithmetic of vectors, a vector v can be represented as an ordered pair of real numbers, v equals or greater than a, comma, b,
Oh, so pause right there. So I know, yeah, those are actually they are the symbols for less than and greater than, but we're actually going to use them as like notation to just tell the reader that it's a vector. So they're not actually like less than or greater than. You just say like A and B. Like you don't have to say them.
Okay, so vectors A and B, where A is the horizontal component of V and B is the vertical component of V.
Okay. Just one more clarification. So, technically A and B are the components of V. So they themselves are not vectors, but it's just components of vectors. Okay. But yeah, thank you for that. Just make sure you have this in your notes. So yeah, every vector V can be broken down into two numbers, right? A and B, right? So essentially it's just two-dimensional. This is just saying that it's two-dimensional. And you can think about this as a coordinate, right? So like you can graph, as you'll see, we're going to graph vectors on a coordinate plane. All right. Is anyone still copying the highlighted text? All right. Now I'll move on. All right. You don't have to copy down the next paragraph. Like, I do want you to copy down this though, but let me explain the context. So what I would do in class, I would draw this picture on the board without x2 minus x1. So essentially you have an initial point, p, right? Let p be the initial point of the vector v, and q is the terminal point of the vector v. Then the horizontal and vertical components are x2 minus x1, which we denote as a, right, as we see here. And then b is y2 minus y1. Okay, so this vertical coordinate minus that vertical coordinate. And that comprises the component form of this vector. So yeah, please do copy this down. So it says if v has an initial point p and a terminal point q, then v equals a comma b, where a is equal to x2 minus x1, y2 minus y1. Okay, and common question, order does matter. So you always want to do the terminal point and then minus the initial point, right? So take the initial point quantities, subtract that from the terminal point. Okay, so again, just make sure you have the highlighted text in your notes. All right, is anyone still copying this down? Please speak up or type in the chat. Okay, so yeah, hopefully this seems like, pretty simple. Um, yeah, nothing much to it. Okay, so let me just talk briefly about this example. So find the component form of the vector v with initial point 1 comma 2 and terminal point 2 comma 4. So again, we're going to take the terminal point x coordinate 2 and then subtract the initial point x coordinate, that's 1. So 2 minus 1, which is 1. And then we're going to do the same for the y coordinate, which is 4 minus 2, which is 2. Right? So 1 comma 2 is going to be the component form of this vector. Okay, that's all it is. Next, we're going to talk about how vectors can interact with each other. So the arithmetic of vectors, or in this case, as I write here, operations on vectors. Okay, so if you let u equal a1, b1, v is another vector, a2, b2, then if you add two vectors, then all you're going to do is add the components, right? Really intuitive, right? a1 plus a2 plus, comma, b1 plus b2. For the difference, you subtract, right? So a1 minus a2, comma, b1 minus b2. And then lastly, we have a vector times a scalar component. So a scalar, if you remember from physics class, that's a quantity that has a magnitude but no direction. So it's just one dimensional. So that's also pretty simple. It's just you multiply each component of the vector by the scalar. Later on, we're going to see how to multiply vectors with vectors, which one of the methods that we're going to see in this class, or actually the only method, is the dot product, right? DOT, dot product. And then if you take physics C next year, then you're going to see another way to multiply, which is called the cross product. Okay. But yeah, just make sure you have this in your notes. This example here and the operations on vectors. Is anyone thinking of taking AP Physics C next year? All right, so about half of you. All right, very nice, very nice. All right, I see one. But yeah, good class if you want to be go into engineering, or study pure physics. Okay. All right. Does anyone still need the notes here? No. Okay. I'm gonna move on then. All right. Lastly, we're gonna talk about the magnitude of a vector, and then after that, we'll get to the worksheet. Okay. So this is the picture I would draw on the board if we were in class. So describe how you would find the magnitude or length of the vector v. So we're going to use the Pythagorean theorem, right? We have the horizontal and the vertical component a and b, right? And as you can see, it's a right triangle. So the magnitude squared equals a squared plus b squared. Take the square root of both sides, you get magnitude v. And note the notation, it's the absolute value sign. So absolute value of v, which is the magnitude of the vector, is equal to the square root of a squared plus b squared. Okay, this should remind you of, when we were talking about, the modulus of a complex number, right? So if you remember, like a few weeks ago, if we had like a plus bi, then to find the distance from to the origin, right, you just do the square root of a squared plus b squared, right? This is the exact same thing, right? Because vectors, just like complex numbers, are two-dimensional, right? So you have a and b. Yeah, same concept. We're gonna use this Pythagorean theorem to get this formula. Okay. All right, but yeah, make sure you have that in your notes. After you finish copying this, you can go to the classwork, which I'll display here. But if you are done copying this, you can go to Google Classroom. The classwork is labeled classwork 3.13. After this lesson, it's just five questions about what we saw just now. But yeah, does anyone still need the definition here, or this formula? Okay. I feel like the most difficult part about this is just like remembering the notation, right? So if you see like vertical bars around V, that denotes that they want you to solve for the magnitude or the length of the vector. Okay. All right, so if no one needs it, then I'm going to scroll down to the classwork. Oh, that's the solution. Don't want to go there yet. Yeah, so just 5 questions. I'll show the first 4, and then so try to work on these. Take the next 5 minutes to go through it on your own, and then we'll reconvene to go through the solutions together. All right, so 5 minutes. Try these questions on your own. All right, so let me pause you here. Let me go through the solutions. So yeah, just these 5 questions, really similar to the ones that you're going to see on the homework tonight. Or not tonight, but like the homework corresponding to this lesson. All right, first one is pretty simple. You know, you have an initial point -5, 4, and a terminal point 4, 8. And to find u, all you do is you take the terminal point and then subtract the terminal point. Sorry, to take the terminal point, subtract the initial point, right? So it's 4 minus -5, which becomes 9, and then 8 minus 4 is 4. So you get 9, 4. Okay. Second question is probably like the trickiest these questions can become, right? So here you're given the final vector 4, 7, and the initial point, and your task is to find the terminal point. Okay, so just remember that, you know, it's x2 minus x1, comma, y2 minus y1. The initial point is 4, 5, so that's x1 and y1. And the final vector is 4, 7, right? So we can pair x2 minus 4 with 4, and then y2 minus 5, we can pair that with 7. From there, we can solve accordingly. So we get x2 equals 8, right? Adding 4 to both sides. And then here we have y2 equals 12 after you add 5 to both sides. So x2 equals 8, y2 equals 12. So therefore, the terminal point for this vector is 8, 12. Okay. All right, so yeah, make sure you have this down in your notes. For question 3, this is pretty simple, just components of a vector from 3, 3 to 4, 4. So yeah, just 4 minus 3, and then comma 4 minus 3. So this would become 1, 1. Okay, I'll give you a sec to copy these questions down, and then we'll move on to 4 and 5. All right, anyone still need these? All right, if not, I'll move on then. For 4 and 5, okay, so 4 and 5, you'll see questions like this on the homework. So here you have a vector u and a vector v, and you're tasked to find 2u, negative 3v, as well as 3u minus 2v. Okay, so 2u, all you do is multiply by 2, right? So this is a scalar times a vector, so you just multiply each component by 2, so this becomes 8, 10. For negative 3v, just multiply each by negative 3, you get 9, comma, negative 12. For 3u minus 2v, make sure you multiply it out before you subtract two vectors. So 3u, just do the same, right? 3 times 4 and 5, so that's 12 and 15. And then for negative 2v, just multiply each component by negative 2. So this becomes 6, sorry, this would become, oh, sorry, yeah. In this question, I did 2 times each. So negative 6 first, and then 8, and then we subtract. Okay, so I did. Alternatively, you could also do 3u plus negative 2v if you want, but here in my work, I showed just 2v, not negative, right? So 3u minus 2v then. So yeah, that becomes 2 times each of these. That's negative 6, 8. And then you subtract, right? So 12 minus negative 6 is 18. And then 15 minus 8 is 7. Okay, so that'll be your final answer for that. And then lastly, question 5. Here, we're tasked to find magnitude u. So again, just remember that notation. You have to find the magnitude or the length of the vector. So it's square root of a squared plus b squared. That's 12 over 13 squared plus 5 over 13 squared. Square root of that, sum. So that becomes square root of 144 over 169 plus 25 over 169. And then the sum of that is 169 over 169. And then that's the square root of 1, right? So just 1. In other words, this is a unit vector, and which we'll get to in a later lesson. But yeah, the length of this vector is 1. And yeah, you'll see that a unit vector, a vector of length 1, has, we're going to see it a lot in this unit. Okay. All right. So while you finish copying that, let me just close with announcements. One, there is SGI today per usual, 2:47. Drop by if you have questions. Secondly, I think I might have mentioned it in the class, but I might have to quiz on a Thursday just because next 2 Fridays are we don't have school. So, but keep that in mind. That might be a possibility. But yeah, I'll keep you posted about topics list and everything. Okay. All right. But yeah, if you have no further questions, you are free to go, and I will see you all tomorrow. All right. Take care.
Thank you. Have a good day.
Have a good day.
All right. Thanks. You too.